folks, and welcome back to the course. Now we're going to discuss a cool topic. I guess they're all cool, but this is the Java Collections Framework. Interesting idea, interesting situation here. Let's define the Java Collections Framework in this nice little document that I've prepared for you all. The Java Collections Framework, it is a grouping of data structure, data types in Java that share common interfaces and methods. Let's go back to the idea of what a data structure is. We talked about that in the arrays module. A data structure is a grouping or collection of individual pieces of data. And I always give the analogy of a physical, like cardboard box, where you can have individual items in your room, and then if you take those items and put them into a cardboard box, you've got a collection of items in the box. That's kind of what a data structure is. It is a collection or grouping of individual items inside of a structure, and the structure, the analogy of the structure would be that physical box. But back to the idea of collections, the collections framework is it's really a grouping of data structure data types. So different kinds of data structures belong to this collective in Java. And the thing about the collections framework is that these data structures, they share common ways to use them, and it creates a real ease of use for all the data structures. And you'll see as we move on. The framework organizes data structure data types by category. Within these categories, the properties and methods to access the objects are the same, ensuring easy transitions between the data types. So within the framework, you've got these different categories of data types. And really the categories of data types are called interfaces. But within each category of data structure data types, you really are going to use each data structure class. You're going to use them using the same methods and ways. So it's going to be a unified access mechanism. So it really makes these data structures easy to use in Java, because like a certain method will do the same thing no matter which data structure data type you're using the method on. So there's a real kind of unification and symbiosis in this framework. All the classes in the framework are derived from three main categories of list, set, and map. List, set, and map. These are three broad categories of data structure types, and I'll get into what they are a little bit later, like specifically. In Java, the categories are called interfaces. This is a kind of a Java key point, key definition kind of thing. An interface, or these interfaces, are like basic templates that define root capabilities. Now let's get into down here what an interface is in Java. Generically, an interface in Java, it's a basic blueprint for how classes that implement the interface will behave. For instance, any data structure class that implements the list interface must do basic things that every other list that implements the interface does. An interface is kind of like the text says, a blueprint. It defines like a very bare bones structure, and any specific class that is going to implement the interface has to follow these rules that the interface lays out. It's kind of like a contract that says, if you're going to be a part of this group, you got to do this stuff to be a part of this group. That's the general idea of an interface. And again, in the collections framework, an interface is kind of like a category of a data structure or data type. And the main categories, among others, are list, set, and map. Moving down a little bit, each of these interfaces, really categories, has several data structure classes associated with them. All the data structure classes that implement an interface implement the same methods. This creates a consistency across the classes that allows for easy use. So like every individual class that you could say belongs to an interface, they have the same methods, so you know that all those classes, you're going to use them in similar ways, and that creates a consistency, kind of an ease and a comfort in using all of the data structure data types. Now let's look specifically at the at kind of the definitions of each interface or category type. The list interface generically represents an ordered, indexable collection. When I say ordered, I mean the order matters and is constant, unless the programmer changes it. And the order is significant. Think of an array would be kind of belonging to this idea. An array, think of an array, it's ordered in that the order of the items has significance, and it is indexable, meaning numerically you can chart the order of the collection. Like there's an index 0 and index 1. It is indexable. So a list is kind of a standard and more kind of basic data structure as compared to these other ones. It's ordered and indexable, as stated before. Order is significant and numerically indexable with integers. So you can pick out index 3 and get an item, index 12 and get an item, index 0 get an item. Generically, that's what a list is. And everything that implements the list interface, it's going to have a common set of methods to work with lists specifically. Looking at the map interface, it represents a collection of elements stored in key value pairs. So the map is a little bit different to where each of its elements is actually a pair of things, two things, key value pairs. Usually there is some association between the keys and the values, the pairs stored in this kind of data structure. So the map data structure is a collection of pairs. And let's contrast the map with the list. We say that the list is ordered and indexable. Well, the map is not numerically indexable. So there's a difference there where when you have key value pairs, you do not access that using integer indexing. So you see a difference there. And so the map interface has its own set of methods to deal with that. But again, the map is key value pairs. And those of you coming from Python will know a map as similar to the dictionary data type. And then looking at the set interface, a set is an unordered collection that does not allow for duplication. Those are the key points of this one. Unordered and does not allow for duplication. So with the set, the ordering of that data structure is not it's not constant and it's not important. So when you look at a set, the order could change and is not significant. Like it's just a set of items. And it does not allow for duplication, meaning every item in a set is unique. So you can't have, if you have a set of integers, you can't have 3 1s and 3 3s and whatnot. every element is unique, and its sets have their own methods for dealing with them. But contrasting the set with the list, a list is ordered, the order is significant, the set is unordered, where it just does not have an order. It is a collection that is unordered, as stated. And then looking at specific classes that utilize the list interface, you have the ArrayList, which we will be covering soon, the vector, which is like an old school array list, and the linked list, which goes back to the kind of computer science idea of a linked list. Classes that utilize the map interface are the HashMap, which we will cover, tree map, and then the linked hash set. Oh, actually, this is a typo. This would be linked hash map. Gotta correct that. It's really a hash map that conforms to linked list like node structure. And then utilizing the set interface are the hash set, linked hash set, and tree set. I'm not going to cover any of those in this course. And in this module, we're going to focus on the commonly used classes, really the two most commonly used classes within the collections framework, the ArrayList, which you'll see a hell of a lot, and the HashMap, which is the basic map implementation. So folks, let's look at the ArrayList. Move it down, move it down. The ArrayList, it is an ordered indexable sequence that is resizable and utilizes the list interface. Think of an array list as an array that allows you to add and remove items. Key point here. Remember with arrays, the definition of an array in Java and in most languages is it is a collection of one data type, a fixed data type, and of a fixed size, meaning that once you set the size of an array, it cannot change. Contrast this with an array list. In array list, the size can change because you can add and remove items. So it's a resizable array. The array list, as well as the other classes in the collections framework, it is instantiated or created by specifying the data type that it contains in angle brackets. I'm speaking of syntax here. And remember, instantiation is the creation of an object from a class. So when you create an array list, you're going to create it by specifying the kind of data that it contains in angle brackets. What are angle brackets? They consist of the less than symbol followed by the greater than symbol, really like this right here, shown in red, where I have string. String would be the data type. Of course, an array list is a collection of items. It's going to contain items of a certain data type. You got to specify that data type in the angle brackets. So here, this line is the creation of an array list, or the instantiation. You would specify the name, the class name ArrayList, angle brackets, put string or the data type that you're using in the angle brackets, and then this is the variable name, AR. This would be the name of the specific instance of ArrayList. And then you use the new for the instantiation syntax, and then you have ArrayList, string and angle brackets again, and then you have the parentheses, which signifies the calling of the constructor. And that's going to create a new empty array list. And of course, you can add and remove items from the array list. So you can then go to town doing that, and we'll see that soon. The data type in angle brackets must be an object type, not primitive. The primitive types, if you recall, are the data types with the lowercase letters, like int, float, char. You cannot put those in the angle brackets. It's got to be an object type. But luckily in Java, we have object types that kind of mirror the primitive types. So we have object types for integer, float, double, character, and so on and so forth. So you just got to use the object or wrapper class type in the angle brackets instead of the primitive type. And I show examples of equivalent object types that are allowed are integer, float, and character. These are called wrapper classes. And in a nutshell, what wrapper classes are these are classes that are the class version of primitive types. That's a really simple way to say it. So if you want an array list of integers, use the uppercase integer, not the lowercase int, because this will not work. And the angle brackets are in use across the collections framework, and you're going to see when I use HashMap as well, it also uses the angle brackets. And this is an example of the consistent syntax used across the classes in the framework. Now let's get into using array lists realistically and specifically with array list methods. Array lists are mostly manipulated and inspected used by the use of methods. Use methods to use the array list. The first one we're going to look at is the add method. And it's simply called by specifying the variable of the array list, a dot, and then add. And then in the parentheses, you put where you're going to add. And here we're calling it twice, adding hello and world. Our array list is a string array list, so we're adding 2 strings to it. So this is the simple addition of items to the array list. Now let's take what I call a little code break and plug this into online GDB just for a demo. I'm going to grab this array list and then skedaddle into our interface here. Guess I'll do a split screen, although I don't know how well it works with this large ass type. To use items in the collections framework, you've got to import Java util, that package, because all classes in the collections framework are in this package. And now I'm going to create an array list. This creates an array list of strings. Of course, there's nothing in it yet, and it's called AR, and I'm going to add some items to it. Of course, this is a string array list, so you got to add strings to it. So I've added 2 items to it, 2 elements, and I'll print the current status of the array list. And array lists, in contrast to arrays, can be printed very easily using println. I don't have to call a toString or method because the toString is implicit. That's a kind of a side point. But actually, I'm not even going to get into that. Those in the know. But simply, you can put AR, the variable name, in the parentheses, and it'll print the contents of the array list. So let's go. And we see hello and worlds, 2 elements there. Pretty simple. All right, let's move forward. Let's look at the next method called get. Indexing, you might have thought about that. Indexing into the array list is done with the .get method. This is because indexing via the square brackets is not possible with ArrayList. Going back to arrays, remember, indexing into an array in Java is done with those square brackets, where you have the square bracket and then you put in a number specifying the index. You can't do that with array lists. Indexing into an array list is done with the .get method. This is how you access an item based on its index, or an element based on its index. Here's a call to get, where we call it and then we print it. And I'm getting element 1, which is going to be world. Let's demo this idea. Got our array list here, and let's just change this here and use get. And we'll get element 1, world. You see, world is the element 1, the second element. Getting element 0, of course, we'll get hello. What if we try to index one that ain't here? You can probably guess what's going to happen. Index element 10. Error, of course. Index out of bounds exception in your array list because there's no element 10. Alrighty, let's look at one last method here to close out our discussion of array lists. The remove method. The remove method is going to remove an element from an array list. So we've seen adding, and we'll see removing. This method has 2 different forms. The first form is if you give an integer as the argument, it's going to remove the item at that index. So like this one, if you call index with an integer like 0, it's going to remove the element at index 0. The next form is given an object as an argument like a value, it's going to remove only the first occurrence of that object in the array list. So if I specify a string to remove from my array list, it's going to find that string and remove it. Of course, if it doesn't find that, it can't remove it. It might be an error. I don't remember what it does. And I don't know why this is said here. This is like a typo because I've already said this. So disregard that joint. You didn't see it. So let me call, I'm going to demo array. Not array. I'm going to demo remove. Lost my train of thought there. And then we'll close out our discussion of array lists. Live TV, folks. Let's go. All right, so we got 2 elements here. Let's remove. Oops. It's variable name dot remove. And then let's just remove element 1. And then I'm gonna, let's just print out the aftermath of that, printing the whole array list. Hello, yeah. So there's only 1 now because I just removed world, and let's remove element 0 as well, and I should get nothing when I run it. And yeah, we got an empty array list because I removed both of them. And here's the other way to call remove. If I remove based on value or object, Removed hello, kept world, and so world is there. If I try to remove something that ain't there, I actually don't remember what happened, so we'll see. Oh, it just silently continues. So no error if you try to remove something that ain't there. It just doesn't do anything. Silently continues, as I said. So that concludes our discussion of array lists. Now we're going to look at hash maps here in a bit. Continuing our study of the collections framework, we're now going to break down the data type of the data structure hash map. That's a mouthful, right? So in a hash map, it brings up an interesting concept, the concept of what is called an associative array in general computer science. So what a hash map is, it is the general Java implementation of a map, of the map interface. And a map generally stores elements in key value pairs such that each element in the data structure is really a pair of values. So a map is really, it's always has elements in pairs instead of individually. You look at like something like an array or an array list, it's got singular items and it's a collection of those. A hash map is a collection of pairs of items. And I mentioned the associative array. In computer science, generally an associative array is a data structure consisting of associated pairs of items. And a hash map in Java is the Java implementation of an associative array, also called a map. So all this stuff ties together. The pairs in associative arrays, the pairs in hash maps, they have some illogical association to each other. For example, considering if you wanted to group individuals' names and ages for some kind of roster, I don't know, like an employee roster, even though you don't really use ages in regards to employees, but of course you have to know their age in some sense. But for whatever it is, if you have a listing of names and ages, you could turn that into a hash map where the pairs would be an individual's name and their age. Each person would have a name and an associated age. Of course, these are associated: person's name, person age, as we see here in this little chart right here. Here we see a chart with names and ages, and these would be associated pairs that could be used in a hash map. You have Mike, 25, Tabitha, 19, and Dolph, 35. Data type wise, we could break down this association to the name being a string and the age being an integer. If you're going to get into programming terms, of course, name is always going to be a string and age can be an integer because it's a whole number data value. As we move down here a little bit, hash maps in Java, they're instantiated by placing two data types, really class types, in the angle brackets instead of one data type separated by a comma. So remember, with array lists, we were storing one data type in the angle brackets because an array list only consists of a single data type. But when you have a data structure that stores data in pairs, you will have two data types, one for the first thing in the pair, one for the second thing in the pair, and of course separated by a comma. So when you instantiate a hash map, you're going to have the word hash map, angle brackets, and then you're going to have two data types in the angle brackets. And these two data types can be the same or they can be different. Here they're different because remember we're storing name and age, and of course name string integer age. Okay, maybe I said that a little bit the wrong way, but anyway, I got it. So this is how you would instantiate it. This is spanning 2 lines because of the length of the page, basically. And so let's take this and look at it in code to make it a little bit easier to grasp here. I'm going to bring over the online GDB here real quick, and see, this is how the instantiation would look in a line of code. HashMap, angle brackets, data types, and this is the name of the HashMap. And then of course we have the new keyword, and then we have really a restatement of the data type, and parentheses to indicate the running of the constructor, really. So that's how you would instantiate a HashMap. And let's get into how you use a HashMap, really. So typically the usage of a data type is going to come down to the methods, because methods are about functionality, right? Like, what can you do with this thing? A method really defines the functions, as it were. So, like array lists, hash maps are mostly manipulated via methods. To add a key value pair to a hash map, you're going to use the put method. So yeah, you're going to need to add stuff to the hash map, because initially when you create a hash map, like you just saw me create one, it's initially empty. So you got to put stuff into it. And how do you put stuff into it? Via a method called put. Very appropriate, right? So here's a couple of usages of the put method, where we do the name of the hash map dot put, and then in the parentheses you're going to put a key value pair. Okay, we put Mike 25 Tabitha 19, and these entries, they harken back to the chart that I was showing you before. This chart right here, you see Mike 25 Tabitha 19, and here it is in code. So let's grab these lines and actually just put them into Java code and see how the thing goes. Just paste these in here. And I'm going to need to retype the quotes because of the formatting coming from the Word document. I know how to say document, I just said it wrong on purpose. So here we are putting 2 entries, 2 key value pairs into the hash map. And then I'm going to go ahead and print the hash map just so you can see what is in it. And here's how a hash map gets represented when you print it out. See, Mike equals 25, Tabitha equals 19. And this it really shows the association between key and value. And if I didn't mention that before, the first item in your pair is called the key. Second item in the pair is the value. Key, value. Key, comma, value. So if I didn't say it before, I'm saying it now. Yes. Let's keep it moving. Let's talk about how to retrieve items from a hash map. Hash maps are not numerically indexable, but instead they are indexed by the key. Remember I just mentioned the key, which is the first data item in the pair. In our hash map that we're doing, the key is going to be the name, that string. Hash maps are not numerically indexable, but they're indexed by key. So you can't generally see, hash maps are not ordered, so you cannot generally index via an integer by location. There's no index 0, index 1 in that kind of ordering. Hash maps don't work like that. They instead work by you retrieve a value by a key. The keys, which are the first items in each pair, those are the lookup mechanisms. Those are the things that allow you to find data. So the name is really going to be used to retrieve the age in this case. So name will retrieve the age. The keys are used to locate values. Indexing by a key is done with the get method. Get will retrieve a value given a key. So no numeric indexing by order. You will index using the key. The key will retrieve the value. I'm saying it over and over again because it's an important point for y'all to get. So this line of code tells us how to index into our hash map to get the age for Tabitha. You see, I do .get and I put Tabitha in the parentheses, and I get 19 because Tabitha's age is 19. In our case, our hash map is name and age pairs, so you're going to use the name to get the age. And this is really how hash maps work and how maps work generally. It is an associated situation where you're going to use the key to get the value, key to value mapping. And that's where the name map comes from. It maps one data value to another one. Here we are mapping the names to the ages. We're mapping Tabitha to 19. So here we go. A little bit more here is that keys in a hash map must be unique. They have to be unique because they're the lookup mechanisms. Because keys are the lookup mechanisms in a hash map, they cannot be duplicated. Let's think about that for a minute. Keys have to be unique because they're what you use to look up the values. If we had duplicated keys, there would be all kinds of confusion. Let's say we had 5 pairs of name and age pairs, and every name was Tabitha. When you looked up using Tabitha, you wouldn't know, the system wouldn't know which thing to retrieve because all the keys are Tabitha. So you need uniqueness. It's kind of like if, think about home addresses. If you were on a street and you're walking down the street trying to find an address, if every address was the same, how would you know how to find what you were looking for? If you're looking for 2309 Calhoun Street, and then you walk down Calhoun Street and every number on every house is 2309, you wouldn't know which door to knock on. That's the idea here. Keys cannot be duplicated. Values, on the other hand, can be duplicated because they are what is being stored, and they are not the lookup mechanism, so they can be duplicated, and their duplication does not matter. So let's circle back here and use the get method on our hash map in code in online GDB. Let's check that out. Fire it up, and I'll look up Mike here because we already saw Tabitha from the document. So do roster.get oh, and I typed in Tabitha anyway. That's Tabitha on the brain, right? Very good. So I'm going to use Mike. And of course we get 25 because Mike is mapped to 25. So here's an idea. What if we try to look up something that is not here? As you've probably seen before, I like to do the error case as well, just to kind of show you what's up. And as you would guess, it's going to be an error because Dean is not in this hash map. Null. Well, actually it's not an error though. So In other languages, this would be an error because the key does not exist in the hash map, but here it's just null because also because it doesn't exist. So it returns null instead in Java. That's our discussion of hash maps, and now we're going to move to a class within the collections framework called collections. Stay tuned for that. So next up, folks, we discuss the collections class, which is a special class within the collections framework. It is what is called a utility class containing really methods of general use to the other classes within the framework. That's kind of what a utility class is, and you see them in Java quite a bit. Like for instance, the arrays class is a utility class within Java to deal specifically with the arrays, and the collections class is a utility class to deal with really the data structure, data types within the collections framework. So let's dive in here. In addition to the data structure classes that you've seen, like ArrayList, HashMap, actually those are the only two you've seen realistically unless you've done your own study. In addition to those data structure classes and many more within the framework also provides a utility class called collections. This collections utility class contains methods to perform actions on the data structure classes of the collections framework. So they really allow you to do things of general use to most of the collections classes. In this module, we're going to examine a few of those utility methods that operate on lists specifically. So the collections class, it contains methods that act on other types of data structures, but we're just going to look at the ones that pertain to lists, really in the interest of time and brevity and things like that. So the methods in the collections class are static, and as such they are called statically. In Java, calling a method statically entails using the class name, a dot, and then the method name, like this example here. This is a generic example where this is kind of like a template where the first part, the prefix, would be the class name, and actually in this case it would be collections because that's the name of the class, and then it would be a dot and then the name of the method. I've not introduced any of the methods yet, so you won't know what they are, but when the time comes it'll be collections dot whatever the method is. And this is said to be called statically, where this is a general Java thing, but when you call something statically, you have the when you call something statically, you have the class name as the first thing instead of the variable name. Usually when you call a method, it's going to be, think of the methods from, let's see, actually, I don't know if you've seen a lot of these methods, so I can't really name something specifically unless I go back and look through what I've taught you already. But generally, what you've seen so far is when you call a method, it'll be the name of a variable dot method. Well, when you call something statically, it's going to be the name of the class, a dot, and then the method name instead. See, static methods, they belong to the class as a whole and not an individual instance. And that's why they're said to be called statically, because static means belonging to the class, not a certain instance. So that's why you use the class name. When you call something statically, a method statically, it is not called from a single instance. A single instance would be a variable name, something like that. No object is instantiated, meaning no variable is created to hold an object to facilitate a static call. Static methods, like I said, belong to the entire class, not a specific instance, and as such, they are called with the class name instead of an instance variable name. So that's the difference. And I'm using this knowledge to set up the fact that every method that we call from the collections class is going to be called statically. It's going to be collections, which is the name of the class, dot method name, whatever that method is. And you'll see that very soon here with collections.sort. Notice the class name here is first, as I said, and then after the dot you got the method. Now it's abbreviated meth. Shout out to Method Man. I keep thinking of him every time I say method. But anyway, class name dot method name. So now we're going to look at a specific one called sort. Collections dot sort. This is a pretty cool one. So here's this is an example of something that would be useful generally to data structures. This sort method is going to sort a list in ascending order, meaning least to greatest, depending on the natural ordering of its elements. What the hell is natural ordering? Well, natural ordering for numbers, see, natural ordering is specific to the data type. Like, how naturally does this data type get ordered? Like, so for numbers, it's by value, which is, least to greatest. For strings, natural ordering is alphabetical. So there's that. So if you supply numbers to the sort method, it's going to sort them least to greatest. If you supply strings to the method, it's going to sort them alphabetically. And that's actually what we've got here. We've got an array list of strings, and it's going to be sorted alphabetically. So taking a look here, we instantiate an array list called names, and then we use the add method to add Ronnie, Bobby, Ricky, and Mike, the strings to this string array list. You may notice these names, or you may remember these names from the members of New Edition, singing group from back in the day. But I digress. Here we call the method. Here's how you call it. As I said, class name, which is collections, dot sort, and then you have names in here, which is the name of the array list. This is going to sort it, and then we print it. And here is your output of this method. Or actually, here is the outcome of the method, not the output. It's going to be Bobby, Mike, Ricky, and Ronnie. As I said before, when you supply an array list of strings, it is going to sort them alphabetically. And this is in alphabetic order. This is in alphabetic order from lowest in the alphabet to highest in the alphabet. And I'll take the same code and run it through online GDB just for demo purposes. Let's go. Already got it typed in, so let's take it for a run. And as stated in the document, it is Bobby, Mike, Ricky, Ronnie, alphabetical order. Very good, very good. So that is the sort method. I keep wanting to say function because I'm so used to the other languages where methods are functions. All right, let's take a look at binary search next. Binary search, this is the Java implementation of the classic binary search algorithm. Early in computer science education, students are taught about searching and sorting methods, the binary search. I was combining two words there. The binary search is one of those basic computer science methods that are taught to students. I learned it much later in my computing life. Anyway, it'll search a list for an object or a value that you provide. So this is a really simple way to search for something in something else. That's what the binary search method is going to be for. Like you got say you got an array list of 500 items. You want to find a value inside that list. You can use the binary search method to do so. It'll search a list for an object that you provide. What it's going to do, it's going to tell you where it is. It'll return the integer index of the item if it finds it. If it doesn't find it, it's going to return a negative number related to the point at which the object would be inserted into the list if it was in there. Really what you got to remember is that if your search turns up nothing, you're going to get a negative number. Just remember that. You can circle back at some other point and understand the rest of this. Not that it's hard to understand, but I think when you're first learning something, you should keep it simple. And keep it simple to just know that if it's not found, it's going to be a negative number. And that's it. Because any negative number that you get is going to indicate an error, or actually, it's going to indicate that it's not been found. So just leave it at that. And investigate the other piece of this at your leisure once you got this other stuff down pat. The list needs to be sorted prior to being passed to the binary search method. This is only a suggestion actually, because it'll still work if your list is not sorted, but it makes the search more efficient if it's sorted. So you really should if you're concerned about efficiency at all. So let me show you how it runs here. So really, if you use the previous code that I had entered and showed you, we can call binary search on that array list. We do collections, once again calling it statically, .binary search, and then you've got two arguments here. It's the name of the array list and what you're searching for. I'm searching for Ricky in the array list. Then I print out what the output, and it's going to give me a 2 because Ricky is at index 2 in the array list. Let's try this out in code. Let's beautify here. And after this code is inserted, calling the binary search, we get a 2 because this is after it's been sorted. After it's been sorted, Ricky is going to be at element 2. Actually, it's already at element 2 anyway, but it'll be there before and after it's sorted, so it gives you a 2. Moving on here to the last method that we'll take a look at, and I encourage you to take a look at other methods in the collections framework by going to the Java documentation. I believe I've showed you, or at least alluded to where that is. Oracle has the Java documentation, so take a look at your leisure and look at the other methods in collections. But here we're going to look at this one. And this one is collections.shuffle. Pretty cool idea. What shuffle does is it is going to rearrange the elements in a semi-random order, really a random order, whenever it's called. I say semi-random because really random number generators are not truly random in the mathematical sense, because there's always some underlying thing, underlying system, so that's not random. But it'll rearrange them in a random order, and it's like just shuffling a deck of cards, basically. So cool idea. It just takes your list and shuffles it. This can be useful. It's going to be useful for unpredictable reordering, like you're going to use in games, like I just talked about, like a card game or a dice game or anything like a role-playing game where you roll dice. But really, games rely on randomness because that's part of the fun of playing a game. You don't know what's going to happen. And a rudimentary part of that could be using the shuffle method to shuffle up your data structures for a variety of reasons. This method is called by placing the name of the list, or really the array list in this case, in the parentheses. And then what we have here is we have two calls of shuffle, and then we print it out after each call. We have call number 1 right here. We have call number 2 right here. And then after each one, we're printing what the outcome is. Makes 2 calls and prints the outcome. And this shows you what the output could be, but given that it's random, it could be anything, any ordering of these names. So let's pop these lines into online GDB. Find the window. Okay. Alright. Beautify is a cool feature of online GDB. It'll format your code well. Alrighty, let's take a look here, and we shuffle and then we print. So let's do that. Okay, we see 2 random reorderings of the array list. And of course they'll turn out differently a lot of times, but there's only 4 items in the array list, so there's a really small number of ways that they could be organized, so you're going to get a lot of duplication. But in a very basic sense, you can use this for random shuffling. Think of a deck of cards, like I said before. If you have a deck of cards, you shuffle it, you get your 52 cards randomized, and then you can draw cards from that randomized deck. You got the beginning of a poker game or a blackjack game. Good stuff. And that, folks, is the end of the discussion on the collections framework. And with that, you'll hear me in the next module. With that one, I am out.